That observation that Alzheimer's people have drastically reduced living variety. They tend not to socialize as much as people who are resistant to Alzheimer's. That started me thinking about the general range of stimulation and animal studies beyond simple, more or less voluntary isolation that old people often develop the habit of just staying at home and watching television or something. Beyond that, animal studies did various things, isolation at different ages, separating the baby animals from their mothers right after weaning, giving them solitary confinement until they're middle-aged, and even tightening up their environment to the point of holding them so they can't do anything at all. There's a gradient all the way from living in a playground, basically, with slides and wheels and various colored objects, balls to push around and so on, all the way down to being rolled up in a blanket so you can't move. But you see the same things happening. The worse the stress is, the smaller the brain gets. Depression is known to increase cortisol and cause atrophy of all of the tissues, and that includes the brain. So they see that after about 3 years of just being psychologically depressed, people show a smaller a reduction of the brain volume. And animal studies starting in the 1960s at University of California, Berkeley, they first found that animals given stimulation, a big playground to roam in during when they weren't eating and sleeping, they found that they learned better, could solve problems better. And so they examined their brains to see what was happening, and they found that the enzyme cholinesterase was increased in proportion to how much they were stimulated and how well they learned. And they kept that study going on generation after generation and found that it not only increased this enzyme that destroys acetylcholine, it involved enlargement of the whole brain, especially the cortex. And each generation, both the enzyme increased and the brain got larger.
Wow.
So
it's passed on?
In a physiological sort of inheritance, which is getting some study now in the last 10 years. But at the time, they were just interested in the fact that the environment could cause these major biological changes, especially in the brain. But a lot of people said, well, if you're destroying acetylcholine at a higher rate and the brain gets bigger, that must mean you have more activity of the cholinergic nerves making acetylcholine. But that isn't what they found. They found that the enzyme that destroys it was increased as the brain got bigger. And that kind of reasoning without facts shifted over to thinking about the deterioration of the brain in Alzheimer's disease, and they saw that there was less tissue in parts of the brain, especially in the cholinergic part, and no one suggested that maybe overexposure to acetylcholine might have something to do with why the nerves atrophied, because the various stress signals increase the various factors that cause brain shrinkage. So they proposed poisoning the enzyme cholinesterase, which was associated in the animal studies with increased intelligence, memory, and brain growth. They proposed doing just the opposite, poisoning that enzyme to increase the amount of acetylcholine in the brain. And the first drug that was proposed and used according to that theory was tacrine, was the name of the chemical. And several studies by the late 90s, they were seeing that it did absolutely nothing for the Alzheimer's dementia, but it did cause a terrifically high incidence of liver disease.
Wow.
So in the 70s, it happened that Parkinson's disease they were looking around for other things than L-DOPA to treat it with, because that didn't work too well. And some virus treatment investigations had found that a derivative of camphor, or a similar compound that was used to cure herpes and influenza, also had nerve protective action. And they thought, why not use this amantadine, or adamantane amine, to treat Parkinson's disease. And they found that it did benefit Parkinson's disease, which involved, among other things, an excess of acetylcholine.
Okay.
And this amantadine was known right from the time of the virus studies. It was known to be an anticholinergic drug, and it was recognized as an anticholinergic when it was being used to improve Parkinson's patients. But the Alzheimer's people, seeing the success with Parkinson's disease, wanted to try it in their population. But since they were already treating with something that increased the cholinergic acetylcholine, they couldn't very well switch right over to something absolutely opposite to inhibit the cholinergic system. So they suddenly discovered that, as well as being anticholinergic, amantadine and the very similar memantine, they found that they also inhibit the excitotoxins, the glutamate aspartate excitatory system.
Okay.
So suddenly this anticholinergic drug became an anti-excitatory drug and was fit to be used in Alzheimer's patients in combination with tacrine or the galantamine or other drugs to poison the enzyme which this new drug was activating.